Equations whose graphs are a line. And you can also, remember, you should have this one, the word bank up. These things are there, like up here. So linear equation, you can put down what things are and things like that. Yes, sir. You got it last time. Yes, you were. You weren't here last time? So, and the idea here on your word bank, a linear equation, in other words, if we had a graph like this, we were talking about a straight line. A straight line on a line. Linear equations refer to straight lines. The x-intercept is a point where a line crosses the x-axis. So up here, so if I have my line, there's my line across my graph. X-intercept. So on your word bank in that box, you want to make a picture kind of like that that shows where the x-intercept would be. The y-intercept. The point where the line crosses the y-axis. So in this case, right there, that is the y-intercept. And the thing is, these coordinates, the x-intercept is always going to be x, 0. Some number x, 0. The x-intercept is always going to be 0, y. In other words, some number y, but the x-coordinate will always be 0 at this x-intercept. The y-intercept, the x, the, pardon? You're right. Thank you. Oh, those get too close to the board things. So this is always going to be x, 0, 0, y. 0y. So at the x-intercept, the coordinate, the y-coordinate is going to be 0. At the y-intercept, the x-coordinate is 0. Now, the standard form of a linear equation. Standard form. Now notice here on page 313, they have linear equations. Notice all our linear equations, like x equals y. That's a linear equation. 2x plus 3 equals y is a linear equation. X equals 3 is a linear equation. In all these cases, x and exponent on the y. What would be the exponent I put there? 1. 1. They're all to the first power. In other words, they are linear. As opposed to these are linear. Y equals x squared plus 1. That's nonlinear. You were graphing things like this on the last one. You got a curved line. But this is see what 1 over x. To be a linear, everything has to be just an x or a y. If it's an x squared, or if there's an x to the minus first, or an x cubed, or something like that. Or notice even they're multiplying the first equals y to the first. 2x equals a y. And x equals a 3. Y, but here's an x squared. X to the minus first. This is x times y. X is not going to equal y here. Okay? This is x times y. So basically what you have to get is an x equals a y on this. This is what makes it a linear equation. An x equals a y. You might make a note of that on your notes. An x has to equal a y of some sort. Now the standard form, and you know, if you look here on page 315, our standard form real numbers. They're numbers. A, B, and C would be numbers. All right, so horizontal and vertical lines. All right, so horizontal and vertical lines, which means either y equals 0, basically straight vertical or horizontal lines, you're either going to have this form, ax plus 0y equals c, or 0 times x plus by equals c. Remember, a, b, and c represent numbers. But in other words, the number that goes with the x or y here is going to be a 0, which means that what really it looks like, x equals 3. That's a 0. Y equals 2. It's going to look out as a straight line on this, as either a equation of this line. When you see x equals 3, y equals 2, that represents either a horizontal or a vertical line. X's are going to be vertical lines. Y's are horizontal lines. So in other words, if I went up to my graph up here, to graph, that is the y equals 7. Let's say horizontal line, because no matter what value for x, because basically what the y plus 0x equals 7, because no matter what